let's learn about the next application of dimensional analysis, which is to find dimension of a constant in a relation. So let's take an example. Find the dimension of gravitational constant big G. So to find the dimension of gravitational constant, let me give it another color, white, because it's kind of a question as well and it's an example as well. So here we have F is equals to G m1 m2 by r square, which is the formula used to find force due to two masses separated by a distance of r, radius r. A distance of r, not radius. So here we have big G. So just putting big G, we get F times r squared divided by m1 m2. So now let's do some dimensional analysis, shall we? So here the dimension of F is MLT minus 2. MLT minus 2. So MLT minus 2. Similarly, the dimension of R, the distance here, the R is the same as of length. And finally, the dimension of M1 or M2, because they are masses, both are masses, it will be M. So now since the relation is physically correct, it must be dimensionally correct as well. So we can write Z will be same as F d square by m1 m2, sorry, r square m1 m2. So, and let's put the bracket. So now let's do some dimensional analysis. So the dimension of G will be, the dimension of F is MLT minus 2. The dimension of R square will be L squared, because L to the power square. And similarly, the dimension of M1 is M, the dimension of M2 is M. So let's do some quick calculations. I think you can do it in your head, but I'm also gonna do it in my head because I don't want to write it. So M divided by M square, yeah. So let's write the dimension of G will be, so M divided by M square will be M minus 1. So L into L squared will be L cubed, and there is only T minus 2, so it will be T minus 2. So finally we found that the dimensional formula of gravitational constant, universal gravitational constant, will be M minus 1, T L cubed, and T minus 2. Great, amazing. So if you saw this video, you might have thought of something. When we derived relations of various physical quantities, we considered the proportionality constant as dimensionless. So what you have to know now is that it does not have to be dimensionless. In that case, we take dimensionless proportionality constant because it is much more easier to work with, and we only use it for equations that do not have any constant with dimensions. So in this case, where we had the dimension of a proportionality constant, which is big G, we can't really like use the method to derive the relations that we did for other things. So in the next video, we are gonna do some questions. So that's it for today's video. Kind of short, but short and sweet, I would say. So see you in the next one.